Algebra 2, 7.9d, we're going to talk about division and reciprocals of complex numbers. Now we're up to 9 previous videos from chapter 7 where we talked about imaginary numbers and complex numbers. Okay, so if you become lost, just click on this video's description and watch all 9 of those videos to help yourself, okay? So to divide complex numbers, we multiply by 1 using the same techniques that we used when we were rationalizing a denominator with 2 terms. We covered that in video 7.4b. In choosing a symbol to represent 1, we use the conjugate of the divisor. So this is the numerator and that's the denominator, but that's the dividend and that's the divisor. Okay, so we're going to use the conjugate of this divisor. All right. So we would use 3 minus 4i, see, because that's the conjugate, over 3 minus 4i as our 1. We just multiply this times this. All right. So if we have 2 over I, or the quotient of 2 and I, we can divide by the conjugate I over I. That's the divisor. See? I over I. We get 2i over I squared. And we know I squared equals a negative 1, doesn't it? So that means we have 2i over negative 1, which equals a negative 2i. See? Now here's a little bit bigger one. We've got negative 5 plus 9i over 1 minus I. This is our divisor, so we're going to use this to find our conjugate, which is 1 plus I. And we use 1 plus I over 1 plus I as our 1. And we can actually FOIL this, can't we? And we get negative 5 minus 5i plus 9i plus 9i squared. We combine like terms and simplify this. And this is over 1 plus I minus I squared. We combine the terms here. We know this I squared is a negative 1. So that means we have negative 5 plus 4i plus 9 times a negative 1. See? Here's our positive 4 plus 9 times a negative 1. And that's going to be over 1 minus I squared, because this positive 1 and this negative 1 cancel each other out as 0 pair, right? So we just have 1 minus I squared. Now we can combine the negative 5 and the negative 9 to get a negative 14 plus this 4i as the numerator, and we have 1 minus I squared as our denominator. We could also think of it this way. You could look at the negative 5 plus 9i over 1 minus I as negative 5 plus 9 times the square root of negative 1, like we did in 7.4b, and we can rationalize the denominator. You could do it that way. But I didn't think this way was that hard, okay? The way we did it. We just FOILed them and combined like terms, right? Take a look at this one. We've got 2 minus 3i divided by 3 plus 5i. Here's our divisor, 3 plus 5i, so its conjugate is 3 minus 5i, and we're going to use that as our 1, 3 minus 5i over 3 minus 5i. We're going to FOIL this, and you should know how to FOIL now. We FOIL the numerator, we FOIL the denominator, we combine the like terms. We end up with 6 minus a 19i plus 15 times a negative 1, because that I squared is a negative 1. And we get 9 minus 15i plus 15i, and they cancel each other out as a 0 pair. Additive inverses, right? Minus 25i squared, which is a negative 1. So that means we get 6 minus 19i minus 15 over 9 plus 25. 9 plus 25 is a 34, isn't it? So combining like terms, we get a negative 9 minus 19i. See? 6 minus 15 is a negative 9. We can also rewrite it as negative 9 34ths minus 19i 34ths. See? Now, the reciprocal of c plus di is 1 over c plus di, isn't it? Just because this can have a 1 underneath it. If we flipped it around to its reciprocal, it would be 1 over c plus di. We can find the reciprocal of 2 minus 3i and write it in the form of a plus bi by dividing. So we have 2 minus 3i its reciprocal is 1 over 2 minus 3i, and the conjugate would be 2 plus 3i. We're going to use that as our 1 right here, 2 plus 3i over 2 plus 3i. We multiply them together, and we get 2 plus 3i over 4 plus 6i minus 6i minus 9i squared. Here we have a zero pair again, don't we? Additive inverses, so we can just get rid of those. And we have 4 minus 9i squared, which is times a negative 1, isn't it? Because I squared is negative 1. And the denominator is 4 plus 9, because two negatives make a positive, right? So we have a 13 for a denominator. We have 2 plus 3i over 13. We can also split it apart and say 2 thirteenths plus 3i thirteenths. So this 2 thirteenths plus 3i thirteenths is the reciprocal of 2 minus 3i. This up here in the a+bi form. So all we did was we wrote it as a reciprocal. We multiplied it, the numerator, by its conjugate. We multiplied the denominator by this conjugate of the divisor. And we simplified it, and that's what we got. And that is the reciprocal of 2 minus 3i in the a+bi form. And we can check this. We just ask, does the number multiplied by the reciprocal equal a 1? Well, here's 2 minus 3i. We multiply it by what we got, this 2 thirteenths plus 3i thirteenths, and we get 4 thirteenths plus 6, see, I thirteenths. Now we have a minus 6i thirteenths, and these are going to cancel out as an additive inverse, zero pair, right? Then we have negative 3i over here. So that's going to give us a negative 9i squared over 13. And that I squared means a negative 1, right? So we've got negative 9 times negative 1, which is a positive 9. When we add the 4 thirteenths and the 9 thirteenths, we get 13 thirteenths, and it equals 1. So yes, it worked. We did it right. It checks out. Okay? Our next video is going to be 7.10a. We're going to talk about complex numbers of solutions of equations. I'm going to add this video to the Algebra 2 playlist. If you want to see an Algebra 1 video on rationalizing the denominator, that would be 11.5b. So I'm going to have the Algebra 1 Chapter 11 playlist from last year in this description, so you can just click on it. And then look through the list. 11.5b talks about rationalizing the denominator. But so does this Algebra 2 7.4b, if you want to watch it from an Algebra 2 standpoint, okay? Then I'm going to have a link to those 9 previous videos where we talked about imaginary I and complex numbers, okay? It starts at 7.7a all the way through to what we just did, all right? Just click on the description and you'll be fine. I know some of this can be really, really confusing, and it might make you want to pull your hair out, but you should be fine if you remember how to FOIL, and you remember what a conjugate is, and you multiply it by 1, and if you can simplify, just take it one little step at a time, and you're going to be okay, all right? I think you can do this. I'll see you next video. Bye.